Hello. Okay, so today we'll be talking about reading and writing ARMv8 instructions. But before we begin, we're going to go over a few things. So just some beginning notes, all instructions in ARMv8 are 32 bits long, and all instructions start with their opcode. And so opcodes range in length from 6 to 11 bits, and there's sheets and charts with all of them listed out, just so you know them. But so, just for clarification, if the opcode is less than 11 bits, then there's a range for the opcode. So for an example here, the CBZ opcode is only 8 bits. So it ranges from those 8 starting bits, and then from all zeros to those 8 starting bits with all ones at the end. So it has a range of, I believe, 8, yeah. So that is how that's taken care of. If there are not enough bits in the opcode, there's a range of opcodes that all satisfy the condition.
So in this example, we're going to take an instruction which is in assembly language and we're going to put it into binary. So first we're going to identify all the components of the instruction, which are the opcode. And this comes from our handy chart. Which shows us, what order our components come in. And this is RT, RN, and this is the address. Alright, so now we can translate each one into binary. So if we look at our chart, we can see that LDUR is 5 ones, followed by 4 zeros, and then a 1 and a 0, and that's that one. And then register 8, we're just going to put an 8 in 5 bits. 22, we have 1 0 1 1 0. 16 plus 4 plus 2 is 22, and then 24 is going to be 1 1 0 0 0, and we're gonna give it some extra zeros to pad it once we kind of put it in its spot to see how many places we have left. So now to the chart that tells us what order our components are in when it's in binary. We know that it is opcode, address, op2, which for our purposes is just going to be 0 0, but it's an extension of the opcode. Then we've got RN and RT, and so let's get everything in the right order. Let's kind of separate it here. 1 1 1 1, 4 zeros, 1 0. Get the address from over there. Let's go backwards actually first. So we've got RT as 0 1 0 0 0. RN is that. Alright, and here we've got 5 11 plus 10 is 21. Opcode is 2 zeros, is 23. So the address we're going to put into 9 bits. So we've got 5 right here, so we're going to pad it with 4 zeros. And then put it in. And that that is your instruction in binary.
So to start, we have a instruction here in binary, as you can see. And so the first step we will do to turn this into assembly language is to figure out its opcode, which will be the leftmost bits, but you don't necessarily know how many they are. But, so you start reading it off, and then you'll get a chart that is in the assembly language that you're working with. This is the ARM version 8. So we read this off as 1 0 0 0 1 0 1 1 0 0 0. And when you're looking at your chart, you can see that that matches up with the opcode for add. So we can partition that off there. Okay. So we know that this is the opcode. And then from this chart, we can also tell that that is in R format, which let's say right there. There it is. So then if we look at a different chart, that will tell you how the bits are divided in the instruction. So for R format, I have it here. The opcode is 11 bits, and then you have RM, which is the second operand. You have the shift amount after that. Then you have RN, which is the first operand, and RD, which is the destination register. And so all of the registers are 5 bits, and then the shift amount is 6 bits, based off our format. So I like to start from the end and just count my 5 bits in. So here you can see 1, 0, like this is 5 bits, and then this is 5 bits. And then we know that the register after the opcode will also be 5 bits, which is this. And so this is the shift amount. So we can write everything up there. Okay, so now you know what your opcode is, you know what your different registers are, and you know what the shift amount is. So the next step is to put this into assembly language. And there's another handy chart which will tell you the order of which those things go in. But so for our format, we know this is the opcode for add, so it would be add. And then typically you go like right to left with the registers. So RD is 1, so that's X1. Then RN, which is the register, the first operand, and this is the destination register. That looks like it'll be 2 plus 8, which looks like it'll be 10. The shift amount in this case is 0, so we're not worried about that. And then for the second operand, it's looking like it'll be 1 plus 2 plus 16, so X19. And so what this instruction binary is saying to do is to add the values from register 10, register 19, and put them into register 1. Thank you for watching my video!